My name is Christopher Chen, and for my lab, I did acoustic filtering by material and frequency analysis of time-varying signals. So the motivations for this lab were, in the first part, was essentially to learn how to use the software and how the Fourier transform turned the time history into the power spectrum. As for the second part of the lab, it was essentially focused on how materials would act like different filters. These are some of the formulas that were used. Here's the approach and some of the equipment that was used. This is the table that contains each of the 11 tracks, their signal type, their relative frequencies, and then the other peaks that were observed and other notes as well. So for my key findings on the left were essentially things I discussed with TA and Week 2, and more importantly, the microphone validation was done essentially by having tones that were played, and so one would be through the microphone and one would be through the DAQ, and comparing these two results. And generally they matched extremely well, so I knew the microphone worked. Um, One interesting result that I did find though was that I had a low frequency spike from like 0 to 100 hertz that was consistently always there that I was pretty sure came from. This is my experimental design. So my motivation was essentially to explore soundproofing because of how paramount it is in so many industries. And so my question was essentially how do different materials act like filters for acoustic signals. My goals were essentially to see how different materials that are listed above, so a no material, which was my control, aluminum foil, microfiber cloth, baking sheet, styrofoam, cardboard, and paper, how each of them would act like a filter, either low pass, high pass, or like broadband. And also, essentially my procedure was to then use my phone that was playing pink noise and hold that next to the microphone, and in between I would place the material so that I could then measure the response. Here are all my results, which you can read. I thought most of them were pretty normal, but the one I especially want to discuss is my paper result because it did not match the expected result, which is that because paper is so thin and not dense, that essentially I expected there to be very little change. And just like I looked online, there should have been very little change, but in reality, there's a lot of change. And I think this was because I was holding the speaker too far away from the microphone in that trial. So that's probably why that error occurred. And that's just the most interesting thing that I thought of my experiment. Here you can see the power spectrums of each of the materials as they were recorded, and so generally these line up with what was presented on the table on the slide before. Again, we can see how the paper generally did not match. So one issue that I came upon was clipping. So essentially, because my volume was too high, the microphone wouldn't be able to pick up the exact top and bottom edges. So essentially, we cut off some of that noise. Another problem that I found was that because I was placing the speaker and my microphone on the same table, that the sound would be transmitted through the solid surface instead of through the air sometimes, and that would mess up my data. And another thing that I found was difficult was that I had a lot of different objects, and so since it was only me there, it would be pretty difficult to hold all of the items in place. here are my key takeaways. So the first part, I talked about the TA. That's the signal analysis. That's all the week two stuff. But essentially, from my filtering, you can see how different materials they in fact did act like different filters, and also that there was a little bit of issue and errors, but generally it was okay.